Hello everyone, I'm Sneha Sahiti Pamate and I'm going to present you the summary of frequent pattern mining algorithm of data clustering, which I have read this paper and this was written by Arthur Gmek, Ira Essen and Dajalis Wirken. So the abstract for this paper is discovering clusters in subspaces or subspace clustering or related clustering paradigms is a research field where we find many frequent pattern mining related influences. In fact, as the first algorithms for subspace clustering were based on frequent pattern mining algorithms, it is fair to say that frequent pattern mining was at the cradle of subspace clustering. Yet, it quickly developed into an independent research field. So in this paper, the author have discussed frequent pattern mining algorithms have been extended and generalized towards the discovery of local clusters in high dimensional data. In particular, they discussed several example algorithms for subspace clustering or projected clustering, as well as point out recent research questions and open topics in this area relevant to researchers in either clustering or pattern mining. So in this investigation of subspace clustering and associated clustering paradigms, they observed significant pattern mining effects. It's safe that frequent pattern mining methods served as the foundation for the earliest subspace clustering algorithms, though the field quickly developed into its own discipline. In this chapter, they have discussed the frequent and expanded and generalized the search for high dimensional local cluster data. This devotes a lot of attention of subspace clustering. For instance, this area will be helpful to researchers in clustering or pattern mining, in addition to highlighting new research questions and unsolved clustering related challenges. And also, finding groups of objects into a data set that are highly similar is a process known as a data clustering. The only additional information needed for unsupervised clustering is the data's geometry, which is frequently represented by a distance function. And objects that are members of the same group should resemble one another more than members of other groups. In the end, the findings from the clustering are meant to inform the user about the different kinds of things that were included in the data collection. A group of clustering methods that can be used to high dimensional datasets are referred to as subspace clustering. This approach ignores features that aren't important to the particular cluster structure, since clusters don't always exhibit similarity across all their attributes. We require algorithms that can evaluate item similarity across subspaces and identify clusters as a result. Different subspaces might be pertinent for specific clusters, while the remaining irrelevant features might obscure clusters. And the foundation of the subspace clustering paradigm or algorithmic techniques developed for frequent pattern mining, which is relevant to many facets for the problem setting. Given a frequency threshold, the a priori level-wise search for item sets of the rising length is used to find the repeating patterns in transaction database. For instance, a binary database for which every row contains many or may not have a particular item. So the insight is used to slim the field of probable candidates, some item sets which were the length 2, by beginning with all item sets of length 1. So these item sets that having the length 1 are often, whereas the item sets having length 2 cannot come often. They're not that much frequent. These subspaces may be used by clustering algorithms in many ways. The second primary form's objective is to pinpoint subspaces as being essential to the final clustering result. Conventional clustering algorithm can be used to discover clusters within these subspaces. Instead, depending on the clustering model that seems the subspace interesting, one should define why it is interesting based on the previous model. Because regular pattern mining does not have a concept of similarity between neighboring regions, as well as the definition of significant subspace areas, this application is not straightforward. Now coming to the critical analysis part. So the connection found in the data by classification models known as associative classifiers serve as the foundation of the predictions. It is possible to identify limited association rules by converting training data into transactions, and the most common objects and rules have labels from classification as a result of this restriction. Rule sets that have been trimmed of extraneous and superfluous rules that were used to construct the classification algorithm. And negative association rules has been demonstrated to enhance association classifier performance during training and classification. If feature X is not present, classifier cannot exist. So the forms of negative association rules that have been devised and utilized in conjunction with positive rules are X and Y. If the feature is absent, then class Y or else class X. It may not be immediately clear, but frequent pattern mining and clustering have a close link. Some methods that were first developed for frequent pattern mining has been adapted to use the data clustering. The faults of these techniques, which tragically was also transferred or examined in this essay, along with how they have changed in the new environment. The larger the hypospace volume, the harder it is to choose the suitable range when employing Euclidean distance. It is important to emphasize that finding outliners in high dimensional data can be just as difficult as finding them in low dimension. One option is to apply an a priori like search method using the monotonicity and of neighborhoods in data projection. And while reading this paper, there are like two questions that have come to my mind and I want to discuss. Does this approach have any use in the real world? Also, how the substances are filled with distance during clustering, how the process was happening. And here are the references that I have taken this paper from. Thank you so much, everyone.